Hello everyone, this is for section P4. The first part, we're breaking it over 2 days. So some basic PEMDAS rules, parentheses, exponents, multiply, divide, add, subtract. When you have an equation, remember that you're going to be undoing any adding and subtracting first. So the basic idea is when you're solving an equation, you're going to be working up PEMDAS. So you're starting at the bottom, undoing any adding and subtracting. So I'm going to add 2. So 3x is equal to 8. There's no more adding, subtracting, so I go after any multiplying or dividing. Divide by 3. X is equal to 8/3. When you've got variables on both sides, it's where you're partial to starting. You can either start by moving numbers or letters. It really doesn't matter. You're going to end up in the same spot. Once you have it here, where all the variables on one side, then it really starts out with the PEMDAS going up it. So I'm going to start by adding the 2. So I got 8x is equal to 13. Then I divide by 8 just like I did in the previous. Okay, well maybe not just like because it didn't have an 8, but you get my point. When you have an equation, equations have equal signs. When you don't have an equal sign, that's an expression. Expressions don't utilize PEMDAS. You're just adding and subtracting like terms. So this one would be 8x plus 9. That's it. You're not allowed to use PEMDAS. Whereas when you have an equation, that's when PEMDAS applies. So try not to confuse the two. When you're adding and subtracting, you're just doing like terms. When you're here, you have an equal sign. That's when you're undoing things and moving stuff across the equal sign to the other side. You do their opposite. Right? Remember, when you have fractions, you're going to be collecting like terms. You're going to be bringing them together. Whereas when you have an equation, you want them to go away. And I'll talk more about that in future slides here. So this one, I'd have to add like terms. So I'd have 1/3 of an x plus 1/5 of an x. So if you want to think of it this way, how about x over 3 plus x over 5 minus, oops, sorry, not minus, plus 9. I need to get a common denominator to bring those together because they're like terms. The common denominator would be 15. So this one gets multiplied by 5 over 5. This one gets multiplied by 3 over 3. So I have 5x over 15 plus 3x over 15 plus 9. So I'd have 8. Oops, I don't know why I wrote minus all. No, that was fine. I'm adding them. Whew. Okay, apologize. I thought I'd made a mistake with the subtraction. I didn't. Panic alert is over. 8/15 x plus 9 would be your answer. You had to collect denominators in order to do this. Okay, so like on this one, I need to move, because I have an equal sign, I need to move the 1/5 of an x over to the other side. So I got 1/3 x minus 1/5 an x minus 2 is equal to 11. How about move the 2 over, so then I'm just dealing with these fractions on this side. Oops, x is equal to 11, so that's equal to 13, because I'm going to add the 2 over and get 13. Okay. Now here, I still have to get a common denominator. It's 15, just like we saw before, so I'd have 5/15, but this time it's minus, let me write it, 5/15 x minus 3/15 x equals 13. So you're going to get 2/15 x is equal to 13. Come on, x, come on. And now you're multiplying, so to make this go away, you'd multiply by its reciprocal. Alright, 15 times 13, what do we got? 15 times 13, because it's 195. So x would be equal to 195 over 2. Alright, now, let me show you guys an easier way to do this. When you have fractions in an equation, don't collect them, obliterate them, blow them up, make them go away, eviscerate them, get them out of there. When you have an expression, you have to collect them. You can't make them go away, but with an equation, you can. Here goes. If you were going to get a least common denominator for the entire problem, what would it be? 15. multiply everybody, everything, each piece. If something's left out, they're going to get cranky. Multiply everybody by 15. This by 15, this by 15. Whoops. Okay, 15 and 51 are real similar. All right, my dyslexia kicked in once again. All right, and let stuff cancel. 3 goes into 15 5 times, and I got 5x. Minus 30 is equal to 3 goes into 15 5 times. 3 times. Why did I say 5? Holy cow. That higher level math skill keeps killing me. Alright, so then I have 3x plus 165, I believe. Alright, now to solve this, notice in one step, no more fractions, and you're almost done. I'm going to cut the 3x off of both sides. I get 2x minus 30 equals 165. Add the 30 over, and divide by 2. And there it is. That's a lot easier, guys, than collecting the fractions and bringing them together. Make your fractions go away when you have an equation. Blow them out of the water. Here goes. What would your LCD be if you looked at this whole thing? I think it's going to be 30. I think you're really focusing on the 6 and the 5, because the 2 and the 3 will fit in the 6. But the 5 won't, so now it's 6 and 5 is 30. Multiply everybody by 30. This times 30, and this times 30. 5 goes into 30 6 times. 6 times 30 is 18. 3 goes into 30 10 times. 1 times 10 is 10. 6 goes into 30 5 times, so I have 25 minus 2 goes into 30 15 times, so 15x. In one step, no more fractions. It's much more palatable. I'm going to add the 15x to both sides. So I have, I think that's 33. X plus 10 is equal to 25. Subtract the 10. 33x is equal to, oh, why did I say minus 15? Minus 10. So that would be 15. X is equal to 15 33rds. Alright? That's right, because 18, that would be 20, 13, 33. Yeah, I don't see any mistakes. Okay, when you have a 1, then you're really just working with it as if, yeah, I feel like I'm making that a bigger deal than it needs to be. Multiply everybody by 6. Whoops, not 6 over 6, 6. Multiply everybody by 6. Good gravy. I feel like I made a mistake in the last one, threw me off. This reduces, so I have 2x. This reduces, so I have 3x is equal to 42. 5x is equal to 42. X is equal to 42 fifths. Okay, FOIL and difference of square pattern. So FOIL is, so that would be 10x squared plus 8x minus 15x minus 12. So 10x squared, that would be what, minus 7x minus 12. So to factor it, when the leading coefficient is 1, you just ask what multiplies to the end and adds to the middle. So it would be x minus 3, x plus 2. That's the difference of square pattern. If you do it out the long way by actually foiling it, notice that the middle is going to cancel out. The shortcut for this, when you see this pattern, they're identical, but one's a plus, one's a minus, is you square the first thing, minus, square the second thing, and you're done. Difference of square pattern. So when you're looking at this, and I'm asking you to find the LCD, you should recognize the product of those two is this. So this is your LCD. If you'd rather think of it like this, you don't have to. I'm just offering this up as an alternative. X minus 5, x plus 5. This is your LCD. So when I ask you to go ahead and multiply everybody by your LCD, it's the entire LCD Good grief. Let me try to write that over. X minus 5, x plus 5. Everybody gets the entire LCD. So that would be x minus 5, x plus 5. And this would be x minus 5, x plus 5. Okay. The x plus 5 cancels, and you're left with 1 times x minus 5 is x minus 5. I'm going to move this subtraction up so I don't lose it. X minus 5 cancels, and I have minus 3x minus 15 is equal to, all of this cancels, 2. So once that, bam, your fractions are gone, collect like terms, add the 20 over, minus 2x is equal to 22. Divide by negative 2, x is equal to negative 11. All right, and this one over here, your LCD is both of them. So we have to multiply by both. X plus 5, x minus 5 over 1, x plus 5, x minus 5 over 1, and this gets the x minus 5, x plus 5 over 1. Here the x plus 5 cancels just like it did in this last one over here. So you get x minus 5. I'm going to move that subtraction up so I don't lose it. So then minus 3x minus 15, just like it was here. But this right side, nothing's canceling. Remember, this was x squared minus 25 before, times 2. You have to get everybody on one side. Let's collect like terms first. So minus 2x minus 20 is equal to 2x squared minus 50. Bring everybody over. So I'm going to add the 2x, add the 20. So I've got 0 is equal to 2x squared plus 2x minus 30. You have to solve this now. Notice that there's a 2 that would be divisible by everybody, so I'm going to get rid of the 2, so it makes the next step easier. Now, can you guys think of anything that multiplies to negative 15 and adds to 1? I can't think of anything. So what that means is you end up having to do the quadratic formula. So b squared minus 4ac all over 2a. Quick reminder on setting that up. X is equal to the opposite of b, so b is 1, so minus 1 plus or minus 1 squared minus 4 times 1 times negative 15 all over 2a, which would be 2. So let's see, that would be 61. X is equal to negative 1 plus or minus the square root of 61 over 2. I guess in the interest of embarrassing myself, let me make sure I didn't do that wrong in my head. 1 minus 4 times 1, which we don't need, times minus 15. Yep, 61. All right, so that would be your answer for that. Let's pull back up. Okay, anything next? Yep. All right, when they give you one like this, it's an expectation that, or it's an assumption, how about that, that these two are going to be made up inside that. In other words, this thing's going to factor x minus 3, x plus 2. It's pretty much a given. They're going to knock, because if it didn't, all of that would be your LCD. That would just be crazy. All right. So go ahead and multiply by your entire least common denominator. And I know you guys are really tempted to take shortcuts here, but please humor me. Demonstrate you actually know what you're doing by doing the whole thing out and not taking shortcuts. I'm not saying that to make life more difficult for you and make more work. I'm looking for you to demonstrate you understand what you're doing. Minus 2x plus 6. All of that's going to cancel. And also just reinforcing, guys, if you are used to taking shortcuts, you lose why you're doing something. And so when the problem changes and looks a little bit different, sometimes you panic because you're not sure why you were doing stuff in the first place. So there's your final answer. All right, here. both of these are your LCD. So multiply everything by your entire LCD. X plus 2, x minus 3, x plus 2, x minus 3, and x plus 2, x minus 3. Alright, here the x minus 3 cancels, so you get the x plus 2 just like we did in the other one. I'm going to move that up so I don't lose it. X plus 2 cancels, minus x plus 3 equals, this you know from the previous problem is going to be x squared minus x minus 6. Collect like terms. Ooh, wait a minute. It's minus 2x. I made a mistake. Minus 2x plus 6. Holy cow. Who's typing this out? Good gravy. I guess I'm talking and not watching what I'm doing. So that would be minus 2x plus 6. So that would be minus 1x plus 8 is equal to x squared minus x minus 6. And this is matching what I got right there, so that's good. Alright, now pull everything to the other side. So I have 0 is equal to x squared. So that would be, if I'm adding an x and adding 1x, that's going to cancel out. If I'm subtracting 8, so then I have minus 14. If solving this, add the 14 over, take the square root. So you get plus or minus the square root of 14 is equal to x. And you're finished. Alright, that would be for the second part of P4, so the first part's done.